Hello students, welcome you all for the today's lecturing session on module 5. In today's class, we are discussing about what is meant by the signal overlap and what are the solution for the signal overlap. Okay, so in the previous class, Professor Ramanand have discussed about what is meant by the coordinate and sequential motion control in multi-cylinder application. So coordinate and sequential motion control, especially in the multi-cylinder applications like the clamping as well as the stamping operation and the clamping as well as the drilling operation together. So during the coordinate and motion control operation, here we need to use two cylinders like cylinder A and cylinder B. Okay, here during the clamping and the stamping operation, here cylinder A it is used for clamping purpose and cylinder B it is used for stamping purpose. During that, here which cylinder have to perform the extension stroke and which cylinder have to perform the retraction stroke and what will be the sequence, that is very much important. So regarding that, so in the previous class we have discussed about what is meant by the functional diagram for performing the coordinate and the sequential motion control like control diagram, displacement step diagram and positional step diagram we are completely discussed. And during the application of drilling as well as the clamping operation, so one of the problem we observe, it is called signal conflict or signal overlap. So when this problem will going to occur during the multi-cylinder application, that is very much important. So before moving to that, first we need to understand what is meant by the signal overlap. Okay, so observe here. So signal overlap, it is normally occur in the memory wall or the memory device. So memory device, it is nothing but 5x2 direction control wall. Okay, so what is meant by the 5? The 5 it is nothing but 5 ports and 2 it is called 2 position. So then in case of the memory wall or a memory device may receive the signal from both the ends from the pilot walls. Okay, observe here, this is the 5x2 direction control wall, that means it contains the 5 ports and 2 positions. So this is called normally open position and this is called normally closed position, and this memory device may receive the signal from both the ends from the pilot walls. So this is the pilot signal 1-4 and 1-2 from both the ends. Okay, so and there may be a situation, okay, and there may be a situation signals are fed to both the ends of the wall at the same time. Okay, then signal conflict or signal overlap problem is going to occur. That means if the one signal which is already applied on the one end of the 5x2 memory wall and another signal is applied to the other end of the 5x2 memory wall without removing the already applied signal, then signal overlap or signal conflict situation is going to occur. Okay, then very much important, first we need to illustrate what is the 5x2 memory wall condition. Observe here, in coordinate and the sequential motion control, this 5x2 memory wall will switch the position only when single pilot signal is present. Okay, that means this is normally open position and this is normally closed position. This 5x2 memory wall switch the position, that is normally open position or normally closed position only when single pilot signal is present. That means either pilot signal 1-4 or either pilot signal 1-2, then only it will switch to the position. If both the signals are applied or operated simultaneously, then signal overlap or signal conflict situation is going to occur, and that condition this memory wall should be inactive and it will not give any switching position like normally open position or normally closed position. And this can be eliminated with the help of the two solutions, that is called, the one it is called signal suppression method, another one it is called signal elimination method. Okay, I repeat, what is meant by the signal overlap? Here a memory wall may receive the signal from both the ends from the pilot wall. Okay, and there may be a situation these signals are fed to the either end of the wall at the same time, then signal overlap situation is going to occur. So that means if the pilot signal 1-4 and 1-2 is applied simultaneously at both the ends of the 5x2 memory wall, then signal overlap condition will be going to occur. So during the signal conflict or signal overlap situation, this 5x2 memory wall it will be inactive condition. Okay, then how to eliminate or how to avoid the signal conflict or signal overlap situation. That is called, first one it is called signal suppression. So what is mean by the signal suppression? So signal suppression means, in this case, signal which is already applied, signal which is already applied is overridden by stronger signal, okay, by stronger signal, and this method it is called signal suppression. Okay, what is meant by the signal suppression? In this case, signal which is already applied, it is overridden by the stronger signal, then it is called signal suppression. This signal suppression can be done in two ways, that is by using the differential pressure condition and by using the bistable wall with control wall on one side of the differential pressure operation. Okay, for the reliability of the operation, in case of differential pressure condition, two pilot signals like 1,4 and 1,2 having the same pressure level. Okay, so this will be useful for the differential pressure operation. For in case of the bistable wall, both the pilot signal 1,4 and 1,2 should be chosen such that there is some pressure difference between the pilot signal 1,4 and pilot signal 1,2. Okay, and these pressure difference, that means the pilot signal 1,4 and pilot signal 1,2 should be having some magnitude. Okay, it should be having some sufficient magnitude, then it is useful for signal suppression by using the bistable wall. Okay, I repeat, what is meant by the signal suppression? In this case, the signal which is already applied, it is overridden by the stronger signal, and this can be done with the help of the two methods by using the differential pressure operation. In case of the differential pressure operation, two pilot signal 1,4 and 1,2 should be chosen such that two pilot signals should be having the same pressure level for good reliability. So similarly, in case of the bistable wall, here two pilot signal 1,4 and 1,2 should be chosen such that there is some pressure difference between the two pilot signals, and these pressure difference should be having the some magnitude. Okay, so this is regarding to the signal suppression by using the bistable wall. Bistable wall or reversing wall, both are same. Then next method, it is called signal elimination technique. So what is meant by the signal elimination technique? So in case of the signal elimination technique, permanent cancellation of the signal which is already applied with the help of the mechanical method or with the help of the cascading method. So this is the two methods what we are going to follow for signal elimination technique. Okay, so signal elimination technique means the permanent cancellation of the signal which is already applied on one end of the 5/2 memory wall. So this is regarding to the signal elimination technique. This signal elimination technique can be done in two ways. The first one, it is called mechanical method, and another method it is called cascading method. So in case of the mechanical method, we need to use idle return roller wall. Okay, so in case of the mechanical method, we need to use idle return roller wall. So before moving on to the idle return roller wall, first we need to analyze, or first we need to know what is meant by the roller lever type of limit switches. Okay, observe here, this is the roller lever type of limit switches. It is 3/2 direction control valve, that means which contains 3 ports. The one it is called input port, 2 it is called output port, and 3 it is called tank port, and it is roller lever type of operated and the spring return direction control valve. And this roller lever type of limit switches produce the mechanical signal which can be sensed in both the directional motion of the piston rod. Okay, so this is regarding to the roller lever type of limit switches here, which produce the mechanical signal and which can be sensed in both the directional movement of the piston rod. So then what happens in case of the idle return roller valve? So in case of the idle return roller valve, it is also 3/2 direction control valve, and which is fitted to the idle roller mechanism. So this is called idle roller mechanism. Okay, so this is idle roller mechanism. Here this 3/2 direction control valve which is fitted to the idle roller mechanism, which produce the mechanical signal, okay, and which can be sensed only in one direction. That's why it is used in order to avoid the signal conflict and signal overlap problem. Okay. Then the action of the idle return roller valve can be understood with the help of this figure. Okay. Here the use of return roller limit switch for the elimination of signal overlap or a signal conflict problem. Okay. Again, so what is mean by the idle return roller valve or idle return roller limit switch? It consists of the 3/2 direction control valve and which is fed to the control system. Here 3/2 direction control valve, it is fed with the idle return roller mechanism. Okay. So what happens during the operation? When cylinder extends, okay, when cylinder extends, this piston passes over the idle roller mechanism. Okay. When piston passes over the idle roller mechanism, then this idle roller valve is actuated as shown in the figure 1, okay, and it immediately deactivate the valve when the piston reaches to the extreme end position. Okay. So this is the working of idle return roller limit switch. I repeat, when the cylinder extends, the piston passes over the idle roller mechanism and it going to actuate the valve as shown in the figure 1. Once as the piston reaches the extreme end position, it is immediately deactivate the valve. So that means as a result, here the valve generate short output pulse during the forward motion of the cylinder. Observe here, during the return motion of the cylinder, this idle roller valve is going to retract the piston or retract the cylinder without reactivating the valve. Okay, it will not going to reactivate the valve, but it will going to retract the cylinder as well as the piston to the original position. That means during the retraction stroke, it will not going to activate the valve as well as no output is going to generated. So this will going to eliminate the signal conflict or signal overlap problem. So this is regarding to the with the use of idle return roller limit switch. Okay. So now we can also analyze with the help of the pneumatic circuit. So for example, here this pneumatic circuit, it is used for extension and retraction of cylinder A as well as the cylinder B. It is used for clamping and stamping operation. Okay. So during the clamping and stamping operation, the sequence is very simple. So first A plus, B plus, B minus and A minus. So what is mean by the A plus? The A plus, it is nothing but the extension of the cylinder A, and B plus is represents the extension of the cylinder B, and B minus, it is called retraction of the cylinder B, and A minus, it is called as the retraction of cylinder A. Okay. So this is mainly used for the, this sequence is used for the clamping and stamping operation. Observe here, initially when the start button is pressed, what happens? So initially all the direction control valves are normally in the closed position. When the start button is pressed, this 3/2 direction control valve shifted from this normally closed position to normally open position, and this allows pressurized air to flow into the this roller lever type of limit switch, and then this 3/2 direction control valve shifted to normally open position. This allows the pressurized air to flow into the memory device. Okay. So this is called 5/2 direction control valve, and whenever this roller limit switch is pressed, then the pilot signal 1/4 activate the 5/2 direction control valve. This allows the air to flow into the blank end of the cylinder A, and this causes the extension of cylinder A. Okay. Once the extension of cylinder A is going to take place, observe here, what is this? A1 position. Then this A1 position represents the extension of cylinder A. Then observe here, so this is A1. Then this idle return roller mechanism is going to activate after the extension of cylinder A. This causes now the pressurized air will flow from inlet port 1 to the outlet port 2. This causes the pilot signal 1-4 to activate the direction control valve, that is 5/2 direction control valve. This causes the extension of cylinder B. Okay. So once the extension of cylinder B is going to occur, so B1 is going to take place. So what is meant by the B1? So B1, it is nothing but the extension of cylinder B. So this B1, it is linked with this roller limit type of switch. When the extension of cylinder B is going to take place, so this causes roller limit switch to activate, and this causes this 3/2 direction control valve to shift it to normally open position. Once it is shifted to normally open position, then pilot signal 12 actuates the 5/2 direction control valve, and this causes the air to flow into the rod end of the cylinder, and this causes the cylinder B to retract. Once the cylinder B is going to retract, and this will going to causes the idle type of roller limit switch to activate. Once the roller idle type of limit switches are going to activate, this sends the signal to the 5/2 direction control valve, and this causes cylinder B to retract. So this is the sequence what we are going to follow for the pneumatic circuit for the clamping and the stamping operation, with the sequence of A plus, B plus, B minus and A minus. Next we are going to see the same pneumatic circuit analyzation with the help of the cascading method. The next topic, it is called the signal elimination by cascading method. So what happens in case of the cascading method, that is very much important. So in case of the cascading method, for the signal elimination purpose, we are going to use bistable valve or the reversing valve. So what is meant by the bistable valve or the reversing valve, that is very much important. So the reversing valve, it is nothing but it is the 4/2 direction control valve with a double pilot signal. Okay. So the reversing valve, it is mainly used to change over the signal from one end to the another end. That means if the pilot signal having the signal 2 and the pilot signal P2 is having the signal 1-4. If the changeover it is need from the pilot signal 1-2 to 1-4, then the bistable valve or the reversing valves are mainly going to use. So next thing, it is called the signal elimination technique for the stamping as well as the clamping operation with the help of the two cylinder A and B. Okay. Along with the sequence of A plus, B plus, B minus and A minus, we need to demonstrate. Okay. So that means it's a demonstration of cascading method for the clamping as well as the stamping operation with the sequence of A plus and a B plus, B minus and A minus. So during the demonstration, very much first important thing we need to know, it is called, we need to follow the 5 different procedures. So very first procedure, it is called, first we need to draw the positional sketch. Observe here, so this is called cylinder A and this is called cylinder B. So along with that, here we need to use 4 roller lever type of limit switch, spring return, direction control valve, and all the 4 direction control valve initially in the normally closed position. Okay. So initially it will be in the normally closed position. Then here, observe here, A represents the cylinder A and B represents the cylinder B. Then what is the meaning of A plus? So A plus, it is nothing but it represents the blank end of the cylinder A, and it also allows the supply of air to fill the blank end of the cylinder, and it causes the extension of cylinder A. Then what is meant by the A minus? A minus represents the rod end of the cylinder, and this causes supply of air to the rod end of the cylinder and the retraction of cylinder A. Similarly, what is meant by the B plus? So B plus means it is nothing but blank end of the cylinder B. This causes the extension of cylinder B. Similarly, what is B minus represents? The B minus represents the retraction of cylinder B as well as the supply of air to flow into the rod end of the cylinder B for the retraction of cylinder B. Then what is meant by the A0. So A0 it represents the retraction of cylinder A, and A1 represents the extension of cylinder A, then B0 represents the retraction of cylinder B, and B1 represents the extension of cylinder B. Okay, so this is the initial positional sketch for the demonstration of clamping as well as the stamping operation. So next it is called locate and name the valve. So here we need to name the valves for the 4 directional control valve for the stamping as well as the clamping operation. Initially I am naming it as V1, and this is V2, and this is V4, and this is V3, and this is regarding to the sequence of clamping and stamping operation for A plus, B minus and A minus. So next it is called locate and name the valve, right? So for the locate and name the valve, here A0 at V1, then A1 at V0, then B0 at V4, comma B1 at V3. So this is the location of valves for the sequence of clamping and stamping operation. Next it is called locate and name the ports. Okay, so next it is called, we need to name the ports, that is called here V1 for 1, V2 for 2, V3 for 3 and V4 for 4. That means here the V1 it is mainly used for retraction stroke, then V2 for 2, V3 for 3 and V4 for 4 according to the sequence. Next it is called, we need to follow the sequence and what is the stroke, what is the end position and which valve to be actuated for the stroke, that is very much important. The sequence it is like 1, 2, 3 and 4. Okay. So what are the first stroke? The first stroke it is called extension stroke, that means A plus. Second stroke it is called extension of cylinder B, then this is B plus. Then third one it is called retraction of cylinder B, then this is B minus. Then last one it is called retraction of cylinder A, then this is A minus. So what will be the end position? So after the extension of cylinder A, the end position it is A1. Then after the extension of cylinder B, the end position is B1. So after the retraction of cylinder B, end position is B0 or B0, and after the retraction of cylinder A, the end position is A0. Observe here. So during the first stroke, the extension of cylinder A is going to take place. The end position is A1. For the A1, the valve to be actuated is V2. Okay. Similarly, second one it's called retraction of cylinder B. The end position is B1. The valve to be actuated is V3. Okay. Then similarly, this third one it is called retraction of cylinder B. For the retraction of cylinder B, valve to be actuated it is V4. And last one it's called retraction of cylinder A. For the retraction of cylinder A, valve to be actuated it is V1. Next it is called for change over the signal. For change over the signal, now we need to use 4x2 direction control valve with a double pilot signal. Observe here. So this is called normally open position and this is called normally closed position. So here during the normally open position, observe here, when the P1 pilot signal 1,4 is actuate the 4x2 direction control valve, then the highly pressurized air is directly go to the V1. Similarly, then the pressurized air is directly go to the V2, so V2 to output. But what about the V3? So when the pilot signal is activated, then the highly pressurized air from the input it is go to the pilot signal P2. Once the pilot signal P2 is activated, now normally open position it is shifted to normally closed position. Then this pressurized air from here it is goes to the V3. Okay. Then finally the pressurized air is go from to the input to the output through V4, and finally it again reaches to the V1 through pilot signal P1. So this is the circuit connection what we need to observe, okay, for change over the signal in order to avoid the signal overlap and signal conflict problem. So next we are going to analyze the pneumatic circuit for the clamping and stamping operation with the help of the bistable valve or reversing valve. The last topic regarding to the today's session, it is called analysis of pneumatic circuit for clamping and stamping operation with the help of the cascading method. So in case of the cascading method, we need to perform the signal elimination technique with the help of bistable valve or reversing valve. We know that what is meant by the reversing valve or a bistable valve. The reversing valve, it is used to change over the signal from the pilot signal P1 to the pilot signal P2 whenever it is required. So this can be obtained with the help of the two cylinders A and cylinder B along with the 4 3/2 direction control valve. Initially all the 4/3 direction control valve, it is called normally in the closed position, okay, and it is roller operated spring return direction control valve, and this cylinder A and B along with the 4 3/2 direction control valve, it is connected to the reversing valve, and the reversing valve, it is nothing but it is a double pilot 4/2 direction control valve. Okay, so this is very much important for the analysis of pneumatic circuit for clamping and stamping operation. For the clamping and stamping operation, here we have the sequence called A plus, B plus, B minus and A minus. So what does it indicate? So A plus, it is nothing but here the extension of the cylinder A, then extension of the cylinder B, then retraction of the cylinder B, and finally retraction of the cylinder A. So for this sequence, we need to follow the procedure in the cascading method. So in the procedure of the cascading method, we have come up with the table that is called, here we need to have the 4 sequence. The sequence 1, it is called extension of the cylinder A, and sequence 2, it is called extension of the cylinder B, and sequence 3, it is called retraction of the cylinder B, and the sequence 4, it is called retraction of cylinder A. And we are also allocated the valves required to actuate and the end position of the cylinder A for the each sequence. Okay, observe here, for the sequence 1, cylinder A should be extend, and the end position for the extension of cylinder A, it is A1. Similarly, the sequence 2, it is called extension of cylinder B, and the end position for the extension of cylinder B, it is called B1. Similarly, the sequence 3, it is called the retraction of the cylinder B, and the end position for the retraction of the cylinder B, it is B0. Similarly, the sequence 4, it is called retraction of the cylinder A, and the end position for the retraction of the cylinder A, it is A0. And the valve we are already allocated here for the A0, we are allocated the valve V1, for the A1 we allocated the valve V2, for the B0 we are allocated the valve V4, and the B1 we allocated the valve V3. So this is the sequence what we need to achieve with the help of the cascading method, and we have come up with the one single table. Then it is called circuit connection. That means how to connect all the 4 3/2 direction control valve to the cylinder A along with the bistable valve or the reversing valve. That is very much important. So we have done with the help of this circuit connection. So first of all, what is meant by the reversing valve? The reversing valve or a bistable valve, it is mainly used to change out the signal from pilot signal P1 to the pilot signal P2 in order to avoid the signal conflict or signal overlap problem. Okay. So first, initially observe here, pressurized air will flow from P to A. Then here, when the valve V1 is actuated, the pressurized air will flowing from V1 input to the V1 output. Similarly, when valve V2 is activated, pressurized air will flow from V2 input to the V2 output. But in order to avoid the signal conflict or signal overlap problem, the pressurized air from V3 input, it is not enters into the V3 output. Instead of that, it is enters into the pilot signal P2. Once the pilot signal P2 is activated, then the signal is going to change over from normally open position to the normally closed position. Then this pressurized air, it is entered into the V3 output. After that, then pressurized air, it is enters into the wall V4 input to the wall V4 output. Then this cycle is going to repeat. So this is the circuit connection what we need to have for the analysis of pneumatic circuit for clamping and stamping operation with the help of the sequence like A plus, B minus and A minus. Okay. So now the circuit connection is made. Now we need to analyze the or illustrate the clamping and stamping operation with the sequence of A plus, B minus and A minus condition. We have already know that what is meant by the A plus. So A plus is nothing but extension of cylinder A. A minus means retraction of cylinder A, B plus means extension of cylinder B, and B minus means retraction of cylinder B. And along with that we also have the 4 walls, that is called V1, V2, V3, V4. And then for the cylinder A there is 2 position, A0 it is called retracted position and A1 it is called extended position. Similarly B0 it is called retracted position and B1 it is called extension position of cylinder B. Okay. So now we need to analyze the working. Okay. So initially when wall V1 is actuated by the retraction stroke of the cylinder A. Okay. So due to the retraction stroke of the cylinder A from the previous cycle, the wall V1 is going to actuate. Once the wall V1 is actuated, the pressurized air from the wall V1 it is enters into the 4/2 direction control wall. Okay. Once it pressurized air enters into the 4/2 direction control wall, here it actuates the pilot signal P1. Due to the actuation of pilot signal P1, then this 4/2 direction control wall it is switches over to the normally open position, so that now connection is made from P to A and B to T. Okay. Hence the pressurized air now will flow from wall V1 to the port 1 of the cylinder A. When the pressurized air enters into the port 1 of the cylinder A, then extension of the cylinder A is going to take place. Okay. At the end of the extension stroke of the cylinder A, it will going to actuate the wall V2. Okay. When wall V2 is actuated, what happens? When wall V2 is actuated, then the pressurized air from the wall V2, okay, then the pressurized air from the wall V2 enters into the port 2 of the cylinder B. Okay. When pressurized air enters into the port 2 of the cylinder B, then cylinder B is going to extend. Okay. So the pressurized air from the wall V2 enters into the port 2 of the cylinder B, then extension of the cylinder B is going to takes place. At the end of the extension of cylinder B, the wall V3 is going to actuate. Okay. When wall V3 is actuate, because of higher pressure of the air, then the signal is enters into the pilot signal P2 of the 4/2 direction control wall. When this P2 actuates the 4/2 direction control wall, now it is changes from normally open position to the normally closed position. Then connection is made from P to B and A to T. Okay. Now connection is made from P to B and A to T. Then this pressurized air enters from wall V3 to the port 3 of the cylinder B. Okay. Now this pressurized air enters into the port 3 of the cylinder B, then the retraction of the cylinder B is going to takes place. Okay. Once the retraction of cylinder B is going to takes place, then cam operates the wall V4. When the cam operates the wall V4, then the pressurized air from the wall V4 it is enters into the port 4 of the cylinder A. When the pressurized air enters into the port 4 of the cylinder A, the retraction of the cylinder A is going to takes place. Okay. So this is the sequence what we need to follow for the clamping and stamping operation. Okay. So here without the signal conflict or the signal overlap problem, we are perform the clamping and stamping operation with the sequence of A plus, B minus and A minus with the help of the cascading method. Thank you.